Thank you for coming for the today's session on the balancing act of HanseMerkur's regulatory preparation through process and tool innovation. More talk is going to be about as they started building their cloud-native applications, the SaaS platform, how did the challenges of networking or network security they went into, and how did they solve those problems to become compliant according to the application requirements. So my name is Dhiraj, and I work for Tigera and Project Calico. I basically am a technical engineer and dev advocacy manager there. Rico?
Yeah. My name is Rico Oldenburg. I'm working at HanseMerkur in the IT infrastructure department, actually, and I'm leading the team Cloud Platform Cloud Services. Okay.
Yeah, hi, I'm Tom. I'm a member of the team Cloud Services, and I'm dealing mainly with security stuff.
Okay, thank you. Okay, so before we get started, how many of you know about Project Calico? Can you show me raise of hands? Okay, and how many of you know about Calico? Okay, cool. Okay. So thank you so much. One recap I would like to do on the Calico open source. It's one of those projects which have been always there with the Kubernetes since the start of Kubernetes as the container networking and network policy solution. It basically has helped many of you guys and many of our customers out there with respect to the data plane choice. If you are running eBPF data plane or standard Linux or Windows, basically it works with all the data planes. It supports Kubernetes network policies as you build policies to control the egress access control, do micro-segmentation, tenant isolation, or workload isolation across the board. And then with Calico network policies itself, it basically augments it further. And then it follows the Kubernetes security policy model, so you can deploy the policies as it rolls out. Few things, it works across the bare metal VMs, containers you use across, and it supports the wide graph-based encryption. Thanks to all of you. At any time when you're looking at Calico, most of the time it's 8 million plus nodes which are operating on Calico, more than million plus clusters, and this is continually growing and going its most adopted container networking and security solution. So beyond this, after people generally start with Project Calico, they basically have started to build production application or compliant-based solutions out there for their enterprise or organizations. They generally basically go from Project Calico into one of these two options, like the Calico Enterprise or Calico Cloud. Calico Enterprise is a self-managed version in which you basically put it in your environment and then you run it as your own hosted solution, or SaaS is a SaaS platform which is basically pay as you go or as a subscription model out there. So we host the management plane, but the control and data plane is with you guys. Why people generally drift towards enterprise or the cloud? That's the main thing where enterprises have started to engage more and started to look further up. So these are generally the challenges which we see in the containers and Kubernetes applications. This does not apply specific to the Calico users or anything, but it's generally the trends we have seen in the market across the board, and they play it out very much as the applications mature. So the first one is the networking challenge. Here, people are just looking for pod-to-pod networking for their dynamic environments, right? As workloads are spun up in the Kubernetes pod and the nodes, you are basically looking at making sure that communication always remains there. The second thing, they are looking at this connectivities across the clusters also. Many of the Kubernetes adopters who started that journey 3 years, 4 years back, what we have started to see with them is they have started to build multiple Kubernetes clusters, and in that also, what they are looking at is not just the cluster connectivity, but at the workload or a pod level, they are looking at that connectivity, because many of these clusters are hosting multiple applications, multiple tenants, so you are basically going micro-level type of scenario here that you are trying to get pod-to-pod connectivity across the clusters. The third thing which is very interesting, which we have found nowadays quite a bit with the enterprises, is that most of the enterprises have a lot of data behind firewalls, like databases, data sources, or they're working with some type of data source which is behind their firewall, which can be Fortinet, Checkpoint, Azure Firewall, AKS Firewall. And what they need is their workload to give a specific IP to the firewall guy so that you can have established connectivity. What happens generally is with the workloads in Kubernetes, those IPs are not static. So that is the challenge they run into, and they try to find some creative solutions to basically address them. The next one goes further in after establishing the connectivity into the security piece. Here the thing is, generally it comes from the compliance side, or it comes from the point of movement of a risk across in the cluster itself, across the nodes, across the pods. And what people are generally looking in this situation is to prevent the risk of lateral movement of threats, right? Like you don't want, if a threat is in one tenant, to go into other tenant, or you can say workloads. The second one they are looking at is granular egress access control, which can be domain name based or IP based. Because of the situation, you can't open up a CIDR range or domain names and then try to provide egress access, because it just creates this situation of attack coming in and then spreading within your cluster. And the last one, which we have started to see towards the applications which are basically built by small and medium businesses, and they're trying to consolidate the network security with network threat detection, that you try to put all type of IDS, IPS, web application firewall, etc., onto the workload itself. So if you have a multi-tenant environment, what you start to see is that one of my tenant wants this network threat detection, other one does not, right? Or one application or workload needs it, not the other one. So I don't want to bog my entire cluster with it, but I want to have every workload based. And the last one is the one where everyone starts to realize, what have I built? What am I working on? What type of communication is happening? Is the connectivity set right? Where is my upstream, downstream dependencies? Or even if I put in the policies, where policies should I, basically, are those policies working as needed or as observed or not, right? So those type of things start to happen. So people are looking into visibility, into service-to-service communication, visibility into security policies, and also like network data impacts, right, for troubleshooting. So in the case of HanseMerkur, what we started to see is there were some of these use cases which come into the play as they started to basically go for a production application, which basically had to be compliant. And these were some of the things which we generally see: observability troubleshooting, microsegmentation, egress access controls, audit and evidence reporting for compliance, egress gateway for fixed IPs, and then cluster mesh. So what we started to see as they started to build it out, these were the 4 things which they needed quite a bit. And I'll let Rico speak to it, how they basically went about addressing them and how did their journey start. Thanks, Rico.
Thanks. So I, of course, feel obligated to give you some background information for context about the HanseMerkur, which is an insurance company based in Hamburg. I think most of you might have heard of it because of sponsoring and so on. And we are actually facing our 150th anniversary next year, so big party coming up, I think. At the moment, we are more like 2,400 employees in 2024, about 200 of them in the IT, and 60 of this 200 are in the IT infrastructure department, where Torben and I are from, as we mentioned earlier, the team Cloud Services. We have about 12 million satisfied customers at the moment, mainly in private health insurance, travel insurance, and at the latest, also pet health insurance. So if that's interesting for you, feel free to reach out. Our journey to Kubernetes at HanseMerkur began actually in 2016 by a set of very capable and skilled engineers that started some experimenting and got a project running, which led to the first workload in production on Kubernetes and HanseMerkur by the end of 2017. So it was still on our hypervisor, bound to the legacy network infrastructure and firewall infrastructure that we had at that time. So the clusters had to be separated by network segment. So each cluster had its own dedicated network, mainly based on you want to separate DMZ content from internal content and so on. The classic firewall was, of course, administered by GUI, and requests were via email or Jira. So that was kind of a deal breaker for leveraging the potential dynamics of a Kubernetes environment at that time. And also the firewall rules, they were on the subnet segment, so there was okay, you can use this subnet and no more granular rules for that. Network policies were in place. They were encouraged for developers, but not enforced. And they were also managed by the developers, which we will come later. And also what we found out in that time period is that IP-based network policies are somewhat limited in communication with the so-called old world. So you actually want to use DNS host names for stability, and yeah. And one of the main critique points that we faced in that time was that the clusters were more or less, due to the points that I just mentioned, some kind of black box for the network and security team. So the technical difficulties and concerns aside, there are also a lot of regulatory requests and requirements that we are facing as an insurance company. So those of you working in the financial sector might have an idea what that means. We have an extensive regulatory landscape that maybe not that extensive as the CNCF landscape, but it's getting close and it's getting more complex each day. Who of you have heard of DORA? Are you prepared? Yeah. So that is something that is very present right now, but there is also, before DORA there was the FIGHT, and there is NIS2 and so on. Our data center has to be ISO 27001, I don't know if it's called that in English, certified and so on. So there's a lot of requirements that we have to meet to satisfy our external stakeholders. And some of these core requirements that we will be talking about later on are the segregation of workloads into separate network segments, what we already had. And the segregation of duties is a very big point in our environment. And also a comprehensive and detailed RBAC rule set with, of course, audit logging, and we need full transparency, visibility of all the traffic, and also have to export all the data that we have into security monitoring, like SIEM. So what did we do? What did we learn? What was our approach to face those regulatory concerns and our first technical concerns that we faced? We went bare metal, of course. We do have, I think right now we have 3 bare metal clusters. The production cluster is about 400 CPU cores and 6 terabytes of RAM. So we're using a virtualized control plane, just full disclosure, but all the workers are bare metal. And all those bare metal workers are in one dedicated physical network segment. And we are using Calico in the Enterprise Edition right now to achieve those micro-segmentation, complete segmentation of every workload. Of course, our cluster leverages GitOps processes based on Argo mainly for cluster configuration and deployment. So we are now empowering the developers to write their own network policies, to make changes, adapt. And we are keeping the security in charge via a 4 eyes principle in GitLab merge requests. And that works very fine for us right now. We have about 3,000 merge requests in the last three and a half years, with a mean time to merge under 1 day, which is already very fast in insurance terms, but it's also including draft states and longer discussions about specific, and so we are fine with that. And of course, we are approaching the public cloud with the concepts and adapting them to use it on AWS AKS at the moment, and are planning to go live in the end of 2024. And thereby, I hand over to my colleague, Torben.
Thanks. Then let's see how we solve this technically, and let's dive right in. You've probably guessed it already. We use Calico to tackle most of these challenges. And what you see here is the policy board you get when you log into the Calico Manager UI, and shows these lanes, and they're called tiers. This is how a tier looks like, nothing fancy here. Tiers are a hierarchical construct to group policies, and we don't use it to only group policies, but also to enforce these guardrails we need here. And we make sure that they aren't circumvented by other teams. The policies are processed in sequential order, always from top to bottom and from left to right. And at the end, there's always the default tier, which is very important. For network policies, we actually don't use this UI actively, to be honest, because we deploy everything with GitOps, of course, from the Calico installation itself to the network policies. But what we use it for is a feature called service graph. And that's pretty cool because it visualizes the communication within a cluster. It shows what communication is there between namespaces and external resources like, I don't know, database systems, load balancers, and so on. That's quite nice. Okay, but back to network policies. There are many, many ways to define tiers and to create a entire policy architecture. But yeah, that's how we've done it. And now let's see why this solves the compliance requirements. We use the steering mechanism to implement organizational and technical segregation of duties, Rico just mentioned. There was this requirement that developers must not be allowed to control traffic which enters or leaves their namespace, which is basically ingress and egress traffic. And this kind of traffic is covered by global network policies here in the global tier. Now let's say a team needs access to github.com from their namespace, then chances are good that there's already a policy, then they need to open a merge request and add this label to the namespace, and that's it basically. Or when it doesn't exist, then they can create this merge request with the new policy. It gets reviewed by platform team and security team and merged, and that's it. That's the process. The use cases for network policies in the workload tier are, for example, enabling pod-to-pod traffic at all because of the default deny at the end. And they are fully managed by the development teams here. That's very important. It's not our business, it's completely their business. And we believe that this is exactly the sweet spot between flexibility for the development teams on the one hand, and maintaining a high level of security and fulfilling the compliance requirements on the other hand. But yeah, that's exactly the balancing act here. Now let's see how the global and the workload tier play together First, some real-world numbers. We have a lot of network policies in the cluster, and what you notice here is we have in the staging cluster about twice as many policies as in production. That's because there are usually 2 stages of applications in the staging cluster. There's usually a dev and a test stage, and that's why there are way more policies, network policies in the staging cluster than in production, because in production that's just, production workload. Again, it is covered by the merge request process and 4I's principle, or the global network policies, and the dev teams own their own workload policies. This is how it looks like when you scroll down the global tier in the UI with, several hundred policies which are deployed in our cluster. It takes some time, but at the very end, there's our special policy, and it's called global path, and this is by far the policy with the most lines of code in it, and it's, I would say, also the place where the magic happens here. When the development team decides to manage their own network policies, then they need to add 2 blocks here, one in the ingress block and one in the egress block. And what this means is everything from namespace 1 to namespace 1, which is basically only the intra namespace traffic, is passed to the next tier, to the workload tier, nothing more. Not an allow, no deny, just a pass. And because this is a global network policy, it has, again, to go through our merge request process. So the team needs to submit only one single merge request to kind of allow themselves to create own network policies in the future. And after that, they can create, update, delete policies whenever they want, without us, without the security team. And this is an example for this. The team here has already added their namespace to the global path policy in the global tier. And once deployed, the team can now create a network policy, which is shown here on the right side. And that's basically an allow all policy for their namespace 1. That allows pod-to-pod traffic. Every pod can talk to each other pod within this namespace 1. And with OPA, we make sure that this kind of policy, this network policy, in the workload tier, matches always the namespace selector and the namespace name. And everything else is regulated by standard Kubernetes RBAC. Of course, we make sure that that every team is only allowed to manage their own namespaces. This is just another view of the global path policy in the manager UI. And again, it's pretty huge. But the most important part here is that this concept solves the 4I's principle and the segregation of duties. Another requirement we had was microsegmentation, which means that every namespace has to be isolated from other namespaces. And one basic concept, and I think the standard in traditional firewalls for decades, is the default deny. And that means that when there's no explicit allow somewhere in the rule set before, then the packet gets blocked at the very end. And this is our default deny policy. It's currently deployed in all of our clusters. And I would also say it's the hard way to do. Calico recommends another way. They exclude some system resources, system namespaces in this default deny network policy. You'll find that in their documentation. This policy has a high potential to break the cluster. But if you're very brave, you could just apply this one and see what happens. But what I would also recommend is a Calico feature called staged network policy. You can create every network policy as a staged network policy. And that means that it only previews network behavior without enforcing anything. And that's also pretty cool. Yeah, microsegmentation, check. Next requirement was traffic visibility. And our technical solution for this obviously comes with Calico 2 because it brings an internal Elastic and Kibana, which makes debugging and observability very easy for us as a platform team, but also for the security team. There's no new technology for them to learn. It's like everybody can set some filters in Kibana and is able to analyze traffic issues, I don't know, within minutes. But more important is that we decided to give the development teams access to these logs too. They can now filter for their namespace and filter for denied traffic only. And again, there's no deep network knowledge needed for them to get an idea what policy might be missing, or when they see denied traffic, or when they're facing network timeouts, the application. And it also reduced the number of tickets in our support platform. And the last requirement Rico mentioned just was what's left is the export of these flow logs to the managed VM system. And yeah, luckily that's it. Basically, we were quite happy when we found out that this is everything we need to configure in Calico to fulfill this requirement from compliance. So yeah, I think everybody's happy now. BSE is happy, BaFin is happy, the customers are happy, we are happy. Did we learn something? Yeah, we did. What I would recommend is apply the default deny before deploying anything else. We thought that it's no big deal, and we tried to implement default deny when there was already workload running, and that turned out that that was not a good idea. We needed a few weeks to months, I would say, to fix this and to create network policies for the existing workload. We had to delete the default deny multiple times. That was pretty annoying, and we bothered other teams. Yeah. What we learned then is that the teams are focused, of course, on developing software, not that much on creating network policies and other infrastructure stuff. And the fact that they can participate does not mean that they will, but once they realize that it takes only one single merge request in our central repository to allow special network communication for the application, and that it takes only, I don't know, some hours to get merged, then they will happily do this, because everything is better than, I don't know, waiting a week or so for a Jira ticket to be resolved. Then we had a ramp-up phase in the beginning. We supported the teams actively with creating network policies. We analyzed the network traffic in Kibana with them. That lasted, I would say, a year or so. And meanwhile, I think nearly every new network policy which comes into the platform via the merge request process comes from a development team, which is a big achievement, I guess. And that's probably because we gave them access to flow logs. Yeah. These were our learnings and our technical solutions for these challenges. And I'll pass it over to Dheeraj for the wrap-up.
Okay. Thank you. Thank you, Rico. Thank you, Jim. Any questions for us?
Okay. Thank you, gents. Can I ask you to come? So, round of applause for the gentlemen. Thank you. We do have one. Again, if you have any questions, go on Slido. How do you manage a mean time to merge of less than 1 day? I'm assuming that's 1 day. When you've got 4 iProcess, do you have a team which is full time on just doing merge requests?
Not really. We have two teams actually, the security team and the platform team, and we get notified in our messaging app when there's a new merge request. It can take longer than a day, but yeah, usually someone from both teams always is looking at these messages. And then, yeah, reviews the merge request. And I would say now the review process was more sophisticated a year or 2 years ago when we started, or 3 years ago. And now there are no new complicated things which come into the system, which makes the review process easier and faster.
Do you specify a minimum or a max merge requests, so it's not like 1,000 line change? You cannot create a merge request for 1,000 lines change, because then obviously that would take a lot longer.
Yeah, there are no merge requests which are that big, because in that repository we have namespace definitions, and some network policies. Yeah.
Okay, thank you. Another one. Do you know how much overhead you have with such amount of network policies?
I'm not quite sure if I get the question.
Yeah, the overhead, as in the amount of people. I don't know if the person who
perhaps
maybe shout out.
You can elaborate, whoever.
Or come down after
or
the talk
come down and reach out. Yeah.
Yeah, anytime.
So, got another one. How about IDS IPS?
IDS IPS is managed by another system, by our traditional firewall system, and by the central load balancer, which they sit in front of the Kubernetes clusters, and they face the internet, and they do just this.
Cool, thank you. And how do you handle ingress traffic from the old world to one pod in a namespace?
Exactly, just as I said before, with the load balancer, we use Citrix ingress controller as a component which is running in the cluster, and they populate the routing information and the service information from Kubernetes to the load balancer. Yeah.
Cool. I think that's it. Again, thank you, Dheeraj, Rico, Torban.
Thank you.
One last round of applause.
Thank you.